Good evening to all. My name is Eleftherios Petavratzis, and I am PhD candidate at the Laboratory of Nonlinear Systems, Equation Complexity at the Department of Physics of Aristotle, University of Thessaloniki. Today, I would like to talk about the experimental study of a terrain coverage of an autonomous chaotic mobile robot. And with this title, you can understand that we're going to talk about mobile robots and how we can create strategies for controlling the motion of them. So let's begin. As I said, our first goal is to create strategies that we can control the motion of an autonomous mobile robot. And in order to do that, we decide that we're going to use the chaotic systems. Also, these systems are going to use for controlling the behavior of an alphabet robotic platform. And from this platform, we're going to have some conclusions and future work that it can be done. Our main target is to create a strategy for controlling the motion of a mobile robot. We know that that there are many strategies, but in our case, we decide that we're going to use a chaotic random bit generator. Also, this generator is going to implement it into a robotic platform, and we're going to see how it is performing. For the first stage of our work, we decided that we're going to use the logistic map, which is one-dimensional discrete chaotic system, and it has a very simple form, as you can see. Also, it is very popular because it is very simple and easy to implement into different applications. Here you can see the bifurcation diagram of our system. And you can notice that the values for parameter R until 3.5, the system shows a periodic behavior. And after that point, it's inserted into chaos. Here you can see also the histogram of the logistic map. And you can notice that in two regions, the majority of the values of these systems are concentrated. In order to avoid that behavior, when we want to create the bits zeros and ones, we decided that in these two specific regions, we're going to use a modulo operator, as you can see over there. And after that point, when we are creating these two bits, we are using an XOR function in order to create the final bit, as you can see from this picture. Also, when we created the final bit stream, we tested with the NIST statistical suite, which has 15 different statistical tests. And we saw that our method can create bit streams that are truly random. Our robot, firstly, we decided that it's gonna be moves into 4 different directions, as you can see from this table. But of course, when our robot is moving, sometimes it needs to avoid the collision with the placed obstacles, or we want to avoid the motion outside of the workspace. In order, as I said, in order to avoid these two unexpected behavior, we decided that our robot can turn 45 degrees either clockwise or counterclockwise in order to pass through the obstacles. Of course, there are sometimes that there are two paths that our robot can follow. In that case, we are using a new logistic map that can tell us which path our robot can use. Here you can see the alphabet platform that we have built our robot. And you can see that this platform has 2 wheels, one in each side, as you can see over there. And also there is one omni wheel that it is on the bottom of the platform, and you cannot see from this picture. At the top, we have an ultrasonic sensor that can send pulses up to 5 centimeters and can detect the placed obstacles. Also, in this point, I want to point out that this session can move into 3 different directions. On the center, we have 2 batteries that can give power to our system. And of course, there is an Arduino Uno microcontroller that can control all this platform. So let's talk about each part separately. First, we're gonna talk about Arduino Uno, which is one-dimensional, which is an open source microcontroller board. It has an USB port that can connect Arduino with our PC. And also, this board has 14 digital and 6 analog pins that can be used in order to control all the aspects of our platform. Of course, it can be programmable by Arduino IDE, which is this kind of environment. And also, with this environment, we can create programs that are written in a form of a language that is very similar to C++. Here you can see the ultrasonic sensor that we are using, and it can send pulses. As I said before, it can send pulses that can detect, that can be reflected by the obstacles that we have placed in our workspace. And this sensor has 3 basic disadvantages. Firstly, they are very sensitive to variation in the temperature. That means that the slightest change in the temperature can force this sensor to give us different measurements that are, and this is not something that we wanted. Also, this sensor cannot detect the thin, soft, and small objects. And of course, the third and most important disadvantage is that sometimes when the reflective angle is very small, for the degrees that are lower than 45, then due to the reflection, our sensor cannot detect these kind of objects. For that case, as I said, we said that this sensor can move into 3 different directions and can create a kind of radar that can detect the placed obstacles. Also, we have a Narratory Encoder that it is used for the rotation of our wheels, and you can see that it has a disc on the front, on the middle. On the one side, there is a LED that can send lightings, and on the other side, there is a photosensor that can detect these lighting beams. We notice that the full rotation of our wheel is equal into 40 light detections. And these light detections, these 40 light detections are equal into 21 centimeter distance coverage. Of course, we want our robot to move to 30 centimeters, and you can see why later on. And in order to do that, we want to detect 45 of this kind of lighting beams. Here you can see the complete method that we are using. It is actually the flowchart of our proposed method. And you can notice that we are using 2 different kind of logistic maps. Each one produces a bit stream. These 2 bit streams are combined through an XOR function. And from these 2, from this final bit stream, we are creating the motion commands. Also, these commands are inserted into our robot. Our robot uses these kind of commands for its motion. And according to the distance of the obstacles that are placed, it decides either to follow the command that it has used, or in the case that the distance is very small, in our case 20 centimeters, that our robot can turn 45 degrees either clockwise or counterclockwise in order to avoid the collision with the placed obstacles. Here I can show you a video with our robotic platform and how it is performing. Of course, in that case, here I want to point out that our workspace is divided into cells each cell is equal into 33 square centimeters. Of course, the coverage rate can be measured with this, as you can see over there. And of course, I want to point out that the running time of our method is equal into 80 minutes. I think you can notice that you can see that our robot can detect the boundaries of our workspace, and it can avoid them, as you can see over there. So let's continue. Here I want to show you the coverage progression of our method through time. In each minute, we measure the coverage rate of our method and in which cells our robot can visit. At the left bar of each figure, as you can see, presents the number of visits in each cell. So you can see the progression of our method through time. And here it is a complete study of our method due to the number of visits in each cell. Here we decide that we're gonna test our method into 3 different initial positions. And you can see the difference between each initial position. And also, this is the coverage rate of our study with the same initial position. And you can notice that we managed to achieve almost 95% coverage of our given workspace, which is a very good result for our method. So to conclude, we can say that we used an XOR function in order to create random bit streams, and you can notice that indeed our bit streams are random. Our robot can cover up to 90% of the given workspace, as you can see from the statistics that I have showed you. Of course, the initial position plays a crucial role according to the coverage rate, and of course, to the number of visits. And as a future work, we're going to implement some method that we have created in simulations that can also improve the coverage rate of our method, but also to reduce the number of visits in each cell. And finally, we want to test our method into application into real world. So thank you very much for your attention.